This video will cover using the Overbeck apparatus to measure the electric field and the electric potential. Now the Overbeck apparatus is a very specialized thing just for such a thing, consisting of some auxiliary pieces that we'll put aside for right now. And we'll get to the heart of it, which is actually this plate. The way that it's going to work, we will apply a positive voltage to one electrode, a zero voltage to the other, so that there will be a voltage differential. This will cause electric current to flow and set up a voltage difference. So the voltage right at this point will be 12 volts. The voltage over here will be 0 volts. And we'll measure the voltage with a multimeter. And we'll simply have it connected to ground here, which is 0 volts. And this part will, in effect, move around on this plate. So let's talk about how we do that. First thing we do, first thing I want to do is identify which template we're going to use, because we want one whose holes line up with these electrodes, and that's going to be this one right here. And we need to have these two holes aligned with these two small holes at the top. Go on to the auxiliary device, and that's going to line up where the electrodes are on the sheet of paper that's on top of the auxiliary part. So we'll draw our electrodes, and we're done with this template. Now the next thing we will do is we will actually attach this plate that we're going to measure to the bottom of the apparatus. Got to have the gray side facing outward, because that's the part that you want to take the measurements on. Put the screws in. Tighten them, not too tight, because they just need to make good electrical contact. Now, when we actually do the measurements, we have this thing turned over, like this. Well, I should turn it back over and point out that we're going to stick one of the banana cables in here. The electricity goes through the bar right there, and it gets connected right there, and similarly on the other side. So we'll put the positive voltage here. We'll put the ground over here, and we will supply power from a DC power supply. DC power supplies are subject to more detail later in the course, but the basic idea is it replaces a 12-volt battery. Well, whatever voltage you want, that's the advantage of a DC power supply. So we'll turn it on. Well, before we turn it on, we should make sure all the knobs are turned down to 0. And we want to set it to 12 volts. We have coarse and fine voltage controls. So I try to turn it up, and well, nothing happened. Let's zoom in here a little bit, see why nothing happened, because this is basic operation of the DC power supply. Read right here, the red, it actually says CC, which means current control. And that means that with the current knob being turned down to 0, don't let any voltage come up at all. So just turn this and give it a little bit of a turn, and now it says CV, that means controlling voltage. So I'll turn this up. And now we have voltage. We have 10.3 volts on it right there. So let's actually zoom back out on this, and so we can see the overall apparatus a little better. We will set the voltage to 12 volts. And that also calls for using a digital multimeter, which is another thing we'll go into more detail later. But this particular one, you will want to use it on a DC voltage scale. And DC voltage, DC is marked by a solid line above a broken line. And we have a 600 volt range, a 200 volt range, and a 20 volt range. And since we're going to be working from 0 to 12 volts, we'll put it on the 20 volt range. We'll connect this to ground, and we'll connect this to the other auxiliary part here, which I'm just getting out. This is the probe. The banana plug to measure the voltage plugs in right there. There's an electrical wire that carries it clear down to this tip right there. This tip actually contacts that gray bottom plate, and it's got a little hole where you can mark with a pencil. So the first thing I'm going to do is actually set this to very precisely 12 volts. And we'll go to the DC power supply, turn it to again, it's okay to be just a little bit over. I'm using the core, the fine knob at the end there. We will plug this digital multimeter now into the probe. We'll slip it underneath the apparatus so it is contacting. And arrange this so you can see it well. At this point, it's 6.85 volts. Well, I'm just going to move this around a little bit, and I'll find where it's exactly 6 volts. As I move it toward this, it should go to positive, to nearly 12 volts, and the probe tip won't actually get onto the electrode, so it doesn't go quite up to 12. It should go down to near 0 here, and again near 0, so it should be 6 volts halfway in between. So we'll move it very carefully so that it's very precisely 6 volts, plus or minus about 0.5. Maybe you can do better. Then you take the pencil and simply mark a point. You continue that to find where else it's going to be 6 volts. Let's come over here. Get another point on the paper, and from there it's a matter of going around, and some of the questions you'll want to figure out, of course, as you will probably figure, 6 volts is basically a straight line, but where is it equal to 1 volt? So we'll get it down to 1 volt. And what's going to happen if I go to the back side here is the voltage going to go negative. No, it didn't. It's to get to 1 volt. Move to here. So it's also reading 1 volt over here. So let me move my probe out of the way. So these 2 points right here and here, it's reading 1 volt. And your job when you do this experiment will be to measure out various voltages and see what the shape of these the contours of constant voltage are. And you should understand that the electric field, the relation between that and the voltage, which is also known as the electric potential.